today's lesson is going to explore the relationship between each side in an acute triangle and the sine of the opposite side. So sine is going to be really important today and next lesson as well. So we want to see what I mean by that, and what we're going to have to do is we're going to have to break this acute triangle into two nice right triangles. Now, an acute triangle is a triangle where the angles are less than 90 degrees. All angles are less than 90. So in this one, we see a 25, we see a 75, and the remaining angle is going to be an 80. So all our angles are less than 90 degrees. What we're going to do is we're going to drop a vertical, and we're going to label this H just for simply the height of that triangle. And what we're going to do is we're going to look at the left side and the right side, and we're going to use our basic grade 10 trigonometry. But I want you to notice again which ratio is going to pop up. So when we look at the left side, which is this triangle right here, I'm not going to redraw it. And if we're going to ask to solve for the height of that right triangle, then hopefully what we do is write down what I know. And what I know is I know the angle, I know the hypotenuse, I want to know the opposite side. So I know the angle A, I know the hypotenuse, and I want to know the opposite side. And what that's pointing us to is the sine ratio, opposite over adjacent. So I'm just going to go ahead and I'm going to plug in the numbers. The sine of the angle is equal to the side opposite compared to the adjacent, or compared to the hypotenuse, sorry. And we're going to go ahead and solve these equations as we did in our review class. And in solving it, we are going to see that that's what it is. Now, I could punch that into my calculator and get an answer if I chose. And I'm not going to do that right now. But it would be around 11.5. So if we plugged that into our calculator, it would be around 11.5. And the height would be 11.5, whatever the units are. Well, if we did the right-hand side, it's a different triangle. But what I want you to recognize before we even do anything is it's the same height. It's a shared side. The answer has to be the same. Except if you look at the angle we're going to use and the hypotenuse we're going to use, they're completely different. So let's go ahead and see if it works out. So in this one right here, well, what do I know? Well, I know angle B, and I know the hypotenuse to this one, and I want to know the opposite side. And again, where that points us to is the sine ratio. And again, the sine is going to be very important today. And that tells us to use our sine ratio. And in this side, the sine of 25 equals the side opposite H and over the hypotenuse of this one, 27.4. And again, we could change that sine 25 to something if we wanted to, but I just want to leave this like this right now. And when we solve this, we get 27.4 sine of 25 degrees. And again, if you plugged that into your calculator, you'd get 11.5 as well. So again, what I want you to recognize is we use grade 10 math, and it really didn't matter which side of the which side of this acute triangle we looked at once we made a 90 degree. The answer was the same, and that should physically make sense. So there seems to be a relationship here. First of all, sine was involved in both of these cases, and that's an important thing to recognize off the bat, even though the left-hand triangle and the right-hand triangle are really quite different. So let's see if we can generalize something or notice a pattern, and a pattern is going to be very important. So let's do the exact same thing we did above, except there are no numbers here. There are just our letters. So big A, big B, little b, big C, little c, and that altitude drop the vertical. So let's look at this in terms of the left-hand side and in terms of the right-hand side. And let's see if we can write an expression for H. So again, with the left-hand side, what do I know? Well, I know angle B, and I have the opposite, which is H, and I have the adjacent. And again, what that points us to is sine. So in this one right here, we'd have the sine of angle B is equal to h over little c. So there are no numbers. We're just going to plug that in. And if we isolate h, if we imagine we want to solve for h, we multiply little c times both sides, and here's what we'd have. So here would be an expression for the height if we were going to use the left-hand triangle. And as long as we knew the angle, and as long as we knew how long little c was, we just plug it in and we use our calculator. So let's look at the right-hand side then. Well, again, what do I know? I know angle c. This question would ask us to figure out the height, and I know the hypotenuse. Sorry, let me go back to this. This is supposed to be hypotenuse, right? And that, again, points us to sine. So the sine of angle C would equal to h over little b. And again, we'd isolate h. We'd multiply both sides by little b. And we get h is equal to little b. And again, it's important that I'm calling it little b because those are sides. Sine of big C. And again, what I want us to recognize is that these two things are exactly the same. They are equal. They both represent the same thing in the picture, so they're equal. So what we can do then is we can go ahead and set them equal to each other. So if h is equal to this and h is equal to this, then they both have to be equal to each other. And if we left it alone like that, that might look okay to you, but usually what you're going to see this expression written as is you're going to see it written as fractional form, and you're going to see it written in a really nice way. And the really nice way is simply, hey, why don't I put my b's with my b's and my c's with my c's? So if I divided both sides by sine c, here's what we would end up with. And if I divided both sides by sine b, here's what we would get. We would get the c's with the c's and the b's with the b's. And again, if you have a question of that, we can go over that in class. But here is a really nice way of taking a shortcut to answer a trigonometry question that does not involve a right triangle. What we did when we set h equal to each other is now we took the grade 10 right triangle stuff out, and literally now we have a nice little equation that doesn't care what the triangle looks like. So this is going to be a very powerful, really simple thing that we're going to use a lot in the future. So flip on to the back. If we, again, looked at this, the above triangle, and we made a height from a different vertex. So I'm just going to choose, I'm going to draw the same picture, basically. And again, I apologize for not being able to use a ruler, but this program, this computer doesn't let me do that. So I'm just going to write my little things right here. And here's what I'm going to do. I'm going to make my height that way. And if I went ahead and I used the exact same, what I know, left-hand triangle, right-hand triangle, and I did all the algebra we did above in trigonometry, here's what we would find. One of my h's would look like this, and another one of my h's would look like that. And that looks very similar to what we just did. And I'll come back to that in a sec, but again, if you drew it and you dropped the vertical from a different vertex, what would the expression look like? And what we would hopefully find is our expression would have different letters. So simply what would happen is, in the previous example, we drew the height from A, and did not have an little a or big A in our equation. And again, you see that right here. This is what I mean. When we dropped it from A, doesn't matter which form we look at, you don't have a little a or a big A. Well, in the example we're just going to finish off here, in this case, we drew from C, and did not have a little c or big C in our equation. And you might see it right here. There's only A's and B's. And if we go ahead and we set those things equal to each other like we did before, again, you see the same thing. And if we go, hey, let's go ahead and put the A's with the A's and the B's with the B's, well, if I have A divided by sine A, that's equal to B divided by sine B. And again, what you should see is there is no little c or big C in that. So this is a really powerful little relationship. This equals is so powerful that it basically gives a shortcut. We don't have to make all these grade 10 triangles. We will be able to go ahead and answer questions simply by knowing this nice relationship between a side and the sine of the angle opposite. And that becomes a very powerful thing. It actually makes grade 11 trigonometry easier than grade 10. So in this one right here, explain how you could measure angle F in this acute triangle, determine the figure. Well, really, all we'd have to do is similar to what we did in these previous two examples. We could drop a vertical from E. And again, if we drop a vertical from E, that means in our general formula, we're not going to have little e or big E. And what that will mean is we'll be able to go ahead and figure out what we need to know. And that's what I'm going to show you in a sec. So again, in this one right here, we're going to make two triangles, just like we did. Make two right triangles by dropping a vertical from E. And then use the relationship we found above. So I'm not going to go ahead and do all this work we did right here. All that work there. I'm not going to go ahead and do it and then figure out what these things are and set them equal to each other. I'm just going to go ahead and use those little relationships of the side compared to the angle, the sine of the angle opposite. So in this one right here, again, if you believe that we're not going to have E information, then here's our little formula that we would have. And in doing this, what I want you to see is, well, in this one right here, what do I know? I'll highlight what we know. Well, I know little d. Little d is 37. I know little f. Remember what little f's are, the side opposite. I know angle D. It's right there. The only thing that we don't know is angle F, and that's the only thing that is unknown in our little relationship that hopefully we've just seen. And we're going to get lots of practice looking at this relationship. So the next thing we're going to do is we're just going to plug in all this information. So when we plug it in, we're going to have little d is equal to 37 over the sine of big D, which is 80, and that's equal to little f, which is 28, over the sine of big F. And what we're going to do is we're going to do a little bit of algebra, and we're going to get sine of big F on top. So here's simply what we're going to do. We're going to multiply both sides by sine F, but there's a much easier way to do this. So the much easier way to do this right off the bat is flip both sides. If we flip both sides, and you can do this mathematically, so if we flip both sides, here's what we get. We get the sine of 80 over 37 is equal to the sine of F over 28. Now again, I just want to emphasize that you can do this. So for example, if you had 1 over 2 is equal to 1 over 2, imagine that's where we are right now. If you flip both sides, you'd have 2 over 1 is equal to 2 over 1, and those are true. So again, mathematically, we can do that as long as we maintain equality. Now, there's a really nice thing for doing that, because right now, I want to get sine F by itself, so I need to get rid of this fraction, this number on the bottom, and if I clear the denominator, I can do that, and when I go ahead and I do that, I'll get sine F is equal to 28 times the sine of 80 divided by 37, and when you plug that all into your calculator spits out 7453. So 28 times the sine of 180 divided by 37 is 0.7453. And if you remember from last day, how do you find an angle given a ratio? That's when you push that second sine button. So what we would simply do now is we would go second sine, and our calculator would go, oh, this is what you want me to do. You want me to find that angle. And when we go ahead and find that angle, our calculator is going to tell us 48 degrees. So here's what we really just did based on a simple relationship. We bypassed all the grade 10 algebra and used a new little formula of sorts